Hi friends, hi students. So this is the application number 11 on work done. Once see the what is the question is given here. Two blocks of masses. First mass is given here M1. Second mass is given here M2. In these two masses, M1 is greater than M2. Means M1 is a more mass compared to the mass number 2. These two blocks of masses connected by an inextensible string, nothing but here the string is not stretchable, are passing over a smooth massless pulley. Smooth massless pulley means there is no friction is acting, and massless means we have to negligible type of mass having. The two blocks are released from the same level, means the same height. At any instant t, if x is the displacement of each block, then what is the work done is happening on the system in this case. Okay, so this is the question, application is given. Then this type of numericals or this type of application means maybe numericals how we have to solve. First, according to this information, I'm going to draw the diagram. First, I'm taking the one ceiling, nothing but a very strong surface. So for this one, I'm taking here pulley. This pulley is a massless pulley. Right. This is the pulley here. Okay, right. So this is the string. This string is initially, this is the block 1. Second one I'm taking here also. This is the second block. You please observe in this diagram both the blocks at the same level. This is I'm considering mass M2. This is I'm considering the mass M1. So this is the initial stage of the diagram. Now here this is the string in this case. How many number of strings I'm using means here only one string I'm using. So means here only one tension. So in this is a string means tension force is acting. So one string is nothing but here only one tension only is acting. Tension is always acting away from the object. For M1 the tension is acting upward. That is the tension I am taking here T. Second M2 side also tension is acting away from the object. So this is also tension is the T in this case, because only one string is nothing but tension acting only one tension. That's why I took here T and T. If you want means you can take T1 T1 or T2 T2, but it should be equal, right? So here if you see in the question, this one once you can observe M1 is greater than the M2, means M1 is the more mass, means what will be happen here, the M1 mass is going to downward in this case. This M1 is going to downward in this case. Continuously this M1 is going to downward, but he's telling at any instant, maybe that time is equal to 1 second or 2 seconds or 3 seconds, whatever it is there, but particular instant of time axis displacement is moving. So means maybe the block is moving to down this much in a particular interval of time. So means from center I'm taking from center to center, the distance is given in the application is x. X is the displacement. So how much of this M1 is moving to downward, the M2 also is moving to in this case upward in this case. So same distance, x distance only, it is also moving to upward in this case, right? You please observe in this diagram, m1 is moving to downward, m2 is going to upward in this case. Okay, right. Now first I will find the work done by the gravity on m1. Work done by gravity on mass m1. So work done formula we know already. W, I am taking here W1. Formula actually what in this case? Force into dot x displacement. F means in this case gravity. Work done by the gravity is nothing but in this case force means mass into g, mg. Dot, dot means cos theta, and x is the displacement. How much of this m1 block is moving downward means x. Now we can see cos theta. Dot means here cos theta. Theta is the angle between mg and x in this case. Always if you observe in this case, the weight of the body for m1 is acting downward. So m1 into g. And displacement also is coming to downward in this case. Displacement is increasing to downward. So this is the displacement is how much of it is increasing? X. So x and m1g both are in the same direction. Same direction means theta is equal to 0. Then cos 0 value will be 1 in this. So m1 gx cos 0 degrees, that is equal to m1g x cos 0 value is in this case plus 1. This is the W1 in this case. So I got it here finally. W1 is equal to m1g displacement is x in this case. Work done by the gravity on mass m1 this is. Similarly, if you see the second mass, work done by gravity on mass m2. So there I am taking the one small diagram for this one. This is the mass m2. So for this one gravity is acting downward. So then this is m2g. And in this case the displacement, nothing but the body is moving in this case upward. Nothing but displacement in this case upward. Now angle between these two is in this case 180 degrees. Same formula I am taking here. W2 is equal to here force vector, gravitational force, gravity into S vector. So this is the second body means m2g. S is nothing but how much of displacement is happened means here x cos, we can see cos 180 degrees. 180 degrees. Cos 180 value is -1. So minus m2 acceleration due to gravity into displacement. This is the work done by gravity on mass m2. So now I want to find out the total work done. W is equal to W1 plus W2. That is equal to W1, I got it, M1Gx plus minus M2G into X. In this case, Gx is the common. Okay, 1 minute. 1 m1g minus m2 gx. Here gx is there. This side also gx is there. Now I am taking the common. Then m1 minus m2 into gx. This is the total work done by the gravity on the system. M1 minus M2 into G into X. So here the body is coming to down. The body is in this case what happened coming down. How much of displacement? X. Initially, for suppose see the diagram. This is the initially M1 is at rest. Initially what happened? This is rest. Means initial velocity u is equal to 0. So what happened? M1 mass is more means what happened? This is displacing x distance. This is the final position. So in this case, time is equal how much it took? T time he took this block took the t time. So in this case, final velocity not equal to 0. And this block is moving uniform, that nothing but uniform acceleration due to gravity. Whenever uniform acceleration due to gravity concept will come, we can use the equations of motions. The formula is I'm taking the second equation of motion. S is equal to ut plus 1 by 2 a into t square. So here S is nothing but displacement, nothing but x. U is nothing but initial velocity. Here initial velocity is 0. 0 into t is nothing but 0. Then remaining is 1 by 2 a into t square. So how much of displacement is moved from the initial position to the final position? Here x is equal to 1 by 2 a t square. Now this x value I am substituting in the work done concept. So here we can see work done here w is equal to formula m1 minus m2 into g. Here x will come. X is nothing but now I found it in this case 1 by 2 a into t square. Okay, right. Here what is the a means in this case? Here a is the acceleration of the block. When the block is in this case m1 is coming to downward, the body having the acceleration. How to find the acceleration in this case? Diagram we have to see. Say this is the mass m1 I'm considering. In this case the tension is there upward away from the object means tension is upward and weight is acting in this case m1g. So what is the direction of the acceleration for this block? Means the block is moving to downward, then acceleration will be downward. So that's why I'm taking in this case force also it is there. Actually in this case F1 is equal to formula. What is the force formula in this case? Mass m1 into A according to Newton's second law. So here force is nothing but how many force are there? Tension force acting and m1g also is acting. But which one you will take first means in this case the block is going to downward means acceleration is the downward. That's why I can take m1g the first. So m1g plus opposite direction what is the tension? So minus t is equal to m1a. So m1g minus t is equal to m1a. Equation number 1. Similarly, second body I am taking m2. For this body also weight is acting downward only. So that is m2g and tension is acting upward. Tension is the upward and m1 is coming to downward means automatically m2 is going to upward in this case. So acceleration is the upward. Now we can you can see acceleration upward means tension force is there on the top. Tension force, this one we can see this one tension force Previously the acceleration is downward means m1 j2. Now I will take now t plus, this is the opposite direction is there m2g, so minus m2g is equal to m2 into a. Next, t minus m2g is equal to m2 into a, equation number 2. So add equation number 1 and 2. Add equation number 1 and equation number 2. Then see here, m1g minus t is equal to m1a, t minus m2g is equal to m2a. Addition I am taking. You can observe very carefully. This is the minus t plus t cancel. So what is the remaining? m1g minus m2g is equal to m1a plus m2a. So here what is the common in this case? G is the common. m1 minus m2, g is the common. That is equal to, here m1 plus m2 into a is the common. So this m1 plus m2 we can take that side. Then finally we will get here acceleration a is equal to m1 minus m2 g divided by m1 plus m2. So this is the acceleration of the block. How much of the block is moving with the acceleration means m1 minus m2 g divided by m1 plus m2. m1 plus m2. Now this value I will substitute in the w. Then finally w is equal to here m1 minus m2 into g 1 by 2. Here we can see this is the acceleration. Now this value I will substitute m1 minus m2 g by m1 plus m2 t square. That is equal to, we can see here, this is the m1 minus m2. This is also m1 minus m2. So m1 minus m2 whole square. This is the g value. Here also g is there. So g square. Here t square is there. T square divided by, what is the remaining value here? We can see by 2 is there. 2 into m1 plus m2. This one also. So this is the work done by the gravity. Okay, so total we have two formulas are there, without acceleration and with acceleration. Now this is the final formula work done. W is equal to, this is in terms of the acceleration. When acceleration value we have to substitute. Okay, before one, W is equal to m1 minus m2 into g 1 by 2 at square. This is in terms of the acceleration in this case. Acceleration value we found it. This is in terms of acceleration due to gravity. Due to gravity. Okay. This is the application number 11. Thank you. Thank you so much.